Hi and welcome to my tutorial. In today's tutorial I will show you how to create an application that will create two graphs, one of which will show the CPU usage and the another one will show the memory usage. The memory usage, I mean the current RAM amount in use by the system, in bytes of course. And the CPU usage will be the total processor time for the given moment at which we will scan it. So this tutorial is actually a kind of continuation or advancement in the other tutorial I did a while back about the performance counter control, as some of you have corrected me. And actually about this performance counter, it is a tricky thing, because performance counter is considered a control and it is placed in the toolbox, but to be honest it's not much of a control, since it does not have any graphical user interface, it does not have any events, it doesn't fire any events. So basically it's a class, yes, that will return certain values. And now we will need two performance counters for this application. One will get the percent of the processor time for the graph number 1, and the another will get the memory usage for the graph number 2. Now select performance counter 1, let's rename it something more colorful, say CPU. Now for its category name we will of course set processor. You can select it from the drop down list here. I'm just not using it because I remember the values, and calculating this drop down list actually takes quite some time. Now counter name, percent of process time, instance name. Now instance name in the case of the processor means the core or CPU which we wish to monitor. Now in this tutorial I select total, which means the total processor time in percent, but you can select a given core if you wish to monitor one core, right? Now select total. Here I'll select total, and another performance counter. The category name is memory. The counter name is percent committed bytes in use. Now the instance name in this case is actually equal to an empty string, right? Because don't type anything, don't type total, otherwise you'll get juicy exception here, right? So it's empty, because when it comes to RAM we don't really have any instances to monitor. It's just RAM, all banks at one time, right? Let's change its name to RAM. And now we need to get those values at certain intervals, right? For that we'll use the timer control, and now the interval of this timer is something quite important actually, because if you have a slower CPU or the older type of CPU, the lower the value, the lower the interval gets, the more gaps in the values we have, right? We request, we get. So if this performance counter does not scan does not get the value, it has not enough time to calculate it, it'll just return 0, and this might actually be quite annoying, right? So I've experimented with it and I've checked, some of you have commented it, that 100 milliseconds, which I used in the tutorial, the first one, is too small, and actually I can agree with you as for case of the slower CPUs. So I experimented a bit, and as I I found that a value of 1 second will be satisfactory in case of slower CPUs. If someone has faster CPUs, half a second, so 500 milliseconds, is quite nice and produces nice effects, right? In this tutorial I'll make it half second. Now of course time on enabled. Let's connect the event handler, and that's actually all. Also, if we're here, connect or create an event for the paint, picturebox 1 paint and picturebox 2 paint, right? It's actually quite important because all the drawing of the graph will be done in the individual paint functions of each of the picture boxes. So now, as you know, any function, any graph has two axes. One is the x-axis, which is the argument, right? And the another is the y-axis, which is the value of the function. So we will calculate the value of the function as we go in the time one tick, but for the argument it'll be constant. So let's make a global integer x, which is equal to 0 because we start from the beginning of the picture box, and in timer 1 tick we will increase that value by a certain amount. Now I'm going to increase it by 2 pixels, right? So x plus equals 2. That means that every time timer 1 tick event is fired, the x is equal to x plus 2. So it is increased by 2 every time the timer 1 tick event is fired. Now for the values we will need to scale them to the picture box, right? So in CPU val, you can name it anything, I'll just name it CPU val, is equal to picture box 1, that height, times math. Actually no, we'll need to use costing here, cost it to int math round, because the math round function returns decimals. Math round, and in that math round we will make the performance counter, which is CPU in my case, next value divided by 100, which all of you know from your maths lessons if you had. If you hadn't yet, then well, you know now. And now we will need to get the RAM value. So picture box 2, of course, here will be. Now in my case it's irrelevant because the picture box 1 height is equal to the picture box 2 height. So if it is, you can just leave it picture box 1 if they are exactly the same. And yeah, that's actually enough for the values. That covers the values. Now when we create function and we wish it to be a line, a kind of a shape of a line, right? So we will need to store the points, the individual values at the certain argument. So for that we will need to create list of points. So list of points, I'm gonna name it CPU points, CPU points is equal to new list of points, and this will hold all the values taken by the all the values that are calculated in time 1 tick, right? Now the same for the RAM values. So RAM PT, I'm gonna name it new list of points. And that's actually all for these lists. Now we will need to add the individual values to this list, right? So CPU points, that's add new point. Now this is the argument of the point, so it's x here. And now this is actually kind of important. If you set the CPU value, the line, this graph will be drawn from the top edge of the picture box, and we don't want that to happen. So we will make it picture box 1.height minus CPU value. So what he did here is actually we make the graph line start from the bottom of the picture box, right? And the same with the RAM point. So RAM points, add the new point, of course x, it doesn't change. Picture box 2.height minus RAM value. And now in this time 1 tick we will call the picture box 1 invalidate and picture box 2 invalidate functions. Now some of you maybe know, some of you maybe don't. When we call the picture box invalidate, this function causes the picture box to be redrawn in WM Paint. So when we refresh the picture box in that way, we do not have the flashing effect when it is created sometimes when we clean the picture box with the graphics instance. So now let's go to the picture box 1 paint, so to the final drawing of the line. Now here graphics G is equal to e.graphics. Now a bit important thing is here that if the line, so if the argument reaches the width of the picture box, we want it to go and start from the beginning. So we will clean the value of the points, CPU and RAM points, every time that happens. So if x is greater than picture box 1.width, then x is equal to 0, CPU points clear and RAM points clear. So if you don't give that if statement and you don't clean those lists, then the function will just go on drawing outside the picture box, right? I mean, it'll draw in the picture box, but the user will not see that because it will be outside the bounds of the picture box. So now after that we have fill rectangle. But before that, maybe I'll show you what I want to do. You can run the task manager, and as you can see on those graphs, you can see there's this grid, right? And this actually is kind of nice effect, and we're going to do the same. Now for that we need to add, using system drawing to Z, and now we can use the G fill rectangle new. hatch brush of a hatch style of cross, and I'm going to use the color green. Now this hatch brush will create the grid effect with a green color, and of course we want to fill the entire picture box client area, so picture box client rectangle, and that will make the graph have a grid background, which is kind of nice effect. And after that we will call the G draw lines, new pen. I'm going to use a solid brush here with a color of light green or something like that. So the alpha is 255, red 0, green 255, and blue 100. Now that's going to produce a nice light green, and we will use the CPU PT to array. Now you need to remember that here it needs to be the to array, otherwise it'll just be an error in this place. Now just let's take it all and paste it here. And now actually, because I will invalidate those picture boxes one after another, this statement, this if statement, is not required here, because otherwise it'll just it's not optimal for the program to call the same if statement again and again. It's just useless, not necessary there. But here in the picture box 1 we will also check if the X is greater than picture box 2 width. Now in my case both picture boxes have the same width, so I really don't have to do that, but I just typed it so that you will remember that if you have different widths of the picture boxes, you should do that. And that basically covers the line drawing and everything. Another important thing is to draw a line, one line, we require at least 2 points. Now if we start function, if we start the program right now, it'll give us an error, and actually it'll not show an error, but the picture box 1 will be just a red cross, right like this, because to draw any line we need at least 2 points, right? So we need to create another if statement. So if CPU points that count is greater than 1, then we begin the line drawing. That's not necessary, and the same here. But here we will draw the RAM values, so that's RAM and here RAM. Yeah, that's. And now we can just go here and see that it actually should and is working, right? So as you can see, it's going quite nice. Now I don't know if I said it or if I didn't said it, but as you can see the RAM value stays the same, and it's actually going to stay the same because I haven't closed any application, haven't started any new application. But to show you that it does work, as you can see it temporarily dropped a bit, don't know if you can see, I'm going to start the task manager, and that didn't do much. And now you can see we can compare the graphs. Now to show you that the change in the RAM and CPU will happen, I'm going to close Google Chrome Chrome on my second monitor. Now look closely. When I did that, there is a sudden drop in RAM usage, both here, and an increase in CPU usage. That's because when we close an application, the signal needs to be processed by the CPU. So naturally there is a corresponding CPU spike in the place of the RAM drop, because the kill signal was sent to the machine, right? And it's just at a certain level of 1.71 gigabytes, and it's going to stay there, like so. So as you can see, this application works, and it works well. So thanks for watching, and see you later.